In this example, we begin by constructing a cumulative frequency distribution by filling in this chart. A frequency distribution is just a count of the number of data within each class. So a cumulative frequency distribution is a count of data within that class and anything also included below that class. So when I look at this chart, this one is not organized or sorted in order. So you may actually want to first open it up in StatCrunch. And notice that the values are already immediately pasted, and we'll use data and then sort. I'll select that column and of course sort by that column and compute. I'm going to remove this little pop-up window. So now my data are sorted in ascending order. So I'm going to move that to the side. Let's see if I can scrunch this down just a little bit more. And where it says students in a district, from 1,000 to 1,999, I can quickly count. There are 1, 2, 3, 4 of those schools. And let me grab that window. So from 2,000 to 2,099, there are 1, 2, 3, 4. But a cumulative frequency is not just a count, it also includes anything below that class. So 4 and the 4 before, then I get a total of 8. I do the same thing for 3,000 to 3,099. So that's 1, 2, 3, 4. All right, but even though there's 4 here, I have to count what was also below that or before it. So now I have a total of 12. And so the last one, if I see what's left, that's the frequency of just that class from 4,000 to 4,999. There's a total of 4. But remember, I'm counting everything in that class and before it, so I get 16. One way to quickly check your cumulative frequency distribution is that the cumulative frequency of the last class or the greatest class should also be the total number of data within the set. So that's a quick check that we should have done that correctly. And then next you're asked about the cumulative relative frequency. So these, very similar to just the relative frequency, we're going to take the values that we had before and divide them by the total number of data in the set, which is 16. So I'll bring up my calculator. I'm going to do 4 divided by 16 and 8 divided by 16 and so forth and so on. So I'm going to fill in this next chart with these values. And also a quick check of your cumulative frequency distribution is that the last cumulative relative frequency, I'm sorry, I may have missed the word relative there, this number should be 1. It should represent the total, all of them, 100% of the data. Because remember, you're adding up everything as you go through each class. So next you're asked about which of these is the frequency polygon. Notice that we're going back to just frequencies here. Okay, so that, remember, for each individual class, the frequency was 4. So I'm looking for some 4s for frequency along the y-axis. And the only place I see that is choice D. But also notice what else the frequency polygon does is it includes an additional segment back to the x-axis. That's standard in a frequency polygon. And it also, the x values are actually the midpoints of each class. So this should be, let's see, let me go back up. We had the first class was 1,000 to 1,999, so it should be close to about 1,500. It should be that x value where the y value is 4. And then last, we have the relative frequency ogive, and this one comes from the cumulative relative frequency values. And so this one we had, if I go back up to our chart, these were our values, 0.25, 0.5, 0.75, and 1. And notice where the x-axis starts. It starts here. The x values for each point starts on the upper class limit of the class. So, for instance, the upper class limit of, let me go back. The upper class limit here was 1,999, and so that's going to be the x value, and the y value is 0.25. So when I come down here to check, that should be pretty close to 1,199, just based off of what I see with my scale here. If this is about 1,000, for instance, and that's 0.25, 0.5, 0.75, and 1. You can see how those increase there. And just as a quick check, that last value should be at 4,999, the x coordinate, and the y coordinate should be 1. And that looks to be the case right here. But each of these were increasing by the same amount as we added. We were adding 4 each time, so I should expect something linear.